In this lesson, we will go through a more complex example question involving the ideal gas law. Let's take a look at our problem. A sample of gas occupies a volume of 3 liters at 25 degrees Celsius and 101 kilopascals. What is the volume at 45 degrees Celsius and 175 kilopascals? We'll first note all the information we've been given. From the problem, we know the initial pressure is 101 kilopascals, the initial volume is 2 liters, and the initial temperature is 25 degrees Celsius. For our calculations, we must convert this temperature to Kelvin by adding 273.15, which gives us 298.15 Kelvin. We also know the final temperature is 35 degrees Celsius, or 308.15 Kelvin, and the final pressure is 151 kilopascals. The information that we're looking for is the final volume. Let's begin by writing down the ideal gas law. PV equals nRT. If we rearrange this equation to isolate R, we can see that R is equal to PV over NT. Since we know R is a constant, this means that PV over NT must also be constant. Thus, our initial PV over NT must be equal to our final PV over NT. In this case, since it is the same sample of gas in the initial and final calculations, we know that the number of moles of gas must also be constant. Thus, we can remove that variable from both sides. Let's now rearrange this equation to solve for our desired variable, the final volume. This gives us the final volume equaling the initial volume multiplied by the initial pressure over the final pressure multiplied by the final temperature over the initial temperature. We can now substitute all the variables with the information we obtained from the problem. Performing this calculation, the kilopascal units and Kelvin units cancel out, and we are left with a final volume of 1.39 liters.